Okay. Good evening, everyone. Hi, everyone. Good evening, everyone. How you guys doing? Huh? How you guys are doing? Good evening, everyone. Super. Great, Swati. Rahul, very good. Hello, everyone. Hello. Hello, Ram Charan. Why you are start streaming? Buffering. Okay. We're trying to just sort it out. Wait. Okay. Is it okay, guys? Now, is it fine? Yeah. Is it okay now? No buffering anymore. Okay. Okay. Great. Okay. Namaskaram, Raju. Namaskaram. Okay. Okay, so in the last class, we started with the electronic configuration, isn't it? So in the electronic configuration, I hope all of you understood electronic configuration. Huh? All of you understood electronic configuration. Just give me a thumbs up, guys, so that we can move ahead. All of you understood? Telugu Radu, right? I don't know Telugu. Okay. Okay, guys. Okay, so all of you have understood electronic configuration. Very good, very good. Okay. So now I'll ask just one configuration and then we'll move ahead. Give me the configuration of copper, guys. Give me the configuration of copper. Atomic number 29. Give me the configuration of copper, guys. Copper. Give me the configuration of copper and we'll move to the next topic. Configuration of copper, please. Write the configuration of copper. We'll see. Not this configuration, not this configuration. Orbital configuration, please. Orbital configuration. Okay, very good, Pawan. Very good. 3s1, 4d10. Very, very good, Pawan. Very good. Very good, Beta ji. Very good. So, 3d10, yes. So, actually atomic number is 19. And if you see, the configuration should be 4s2 and 3d9. This should be the configuration, isn't it? Once you write the neon, 18 electrons, neon 18, sorry, argon. Once we have argon, 18 electrons, after that, we need to add these many electrons, yes or no? 11 electrons. To add these 11 electrons, we have first s orbital and 3d orbital. Because we know that 4s ka n plus l value 4 and 3d ka n plus l value 5. So this is higher in energy. So first 4s1, 3d10. Very good, everyone. Very, very good. So this s electron will go in d orbital, d subshell, and so the configuration becomes 4s1, 3d10. Very, very good. Okay, guys. Very good. So now we are starting with some SI units, and then we'll go to some basic idea about how to go about the mass, temperature, volume, and number of moles and these things. So we'll start with the SI unit. So how many types of SI units are there? So for different parameters, we have some SI units, and this is very, very important, and most of the time it will help a lot while solving the numericals. Okay, so what are the SI units we are having? So mass ka SI unit, what we use is kilograms. Okay, represented by symbol M, mass. Then we have length. What is the length ka SI unit? What is the length ka SI unit? Length ka SI unit will be meter. Meter will be the SI unit, and symbol will be small m, meter, right? And what about the length, mass? Then what do we have? Temperature. So what will be the SI unit of temperature? Let me know what is the SI unit of temperature. Temperature ka SI unit will be Kelvin. So temperature ka SI unit is Kelvin, represented by symbol K. And what do we have? Amount of substance. Amount of substance. What is the unit of amount of substance? Bolo beta ji. Amount of substance ka unit is mole, isn't it? Amount of substance ka SI unit is mole. And what do we have? Amount of substance, length, mass, temperature, time. So what is the SI unit of time? Bolo beta ji. Time ka SI unit is always taken at seconds. In second, we are going to measure the time. One more will be there. What is there? Two more actually. One is called as luminous intensity. Luminous intensity. What is the SI unit of luminous intensity? SI unit of luminous intensity is candela. Candela, represented by symbol CD. Seconds ka, this is mole only, MOL. In short form, we write mole. And seconds is represented as small s. And there is one more, current, right? So what is SI unit of current? Bolo beta ji. Current ka SI unit will be amperes. Current ka SI unit will be ampere. Symbol will be A. So these are the SI units we are having, and 7 SI units we have. And this is very, very important to understand few aspects. Very, very important to understand few aspects. In this class, we are going to elaborate some mass and this and that, how to measure the volume and this and that. Okay. So you see, for gases, because in chemistry, generally we will be talking about gases most of the time during physical chemistry. So during that, we will go through an equation which is called as ideal gas equation. For now, most of you, if you don't know, don't worry about it. I'll come to this equation. This is called as ideal gas equation. This is called as ideal gas equation. Now, you will see that most of the students will have the trouble in unit ka interconversion. And I'll tell you, most of the, at least 5% of the problem you can solve without understanding their concepts also, just with the help of unit. So unit is very, very important, beta ji. Unit is very, very important. Okay, please remember that. So we need to understand the unit ka conversion, because most of the time we'll be dealing with the volume, pressure, number of mole, and temperature, this and that. So we are having generally 3. Number of mole ka SI unit is always mole, right? So no interconversion is needed. But for pressure and for temperature and for volume, we need the units ka interconversion. We need the units ka interconversion. So I'm going to teach you how to do the interconversion of pressure, volume and temperature between different units. And then we will start our beta ji gas constant. This is gas constant. इसको अपन बाद में देख लेंगे. This is gas constant. For now, we are going to focus on pressure, volume and temperature, how to do their interconvergence of units. And let me tell you, beta ji, this is very, very important. Okay. Starting with the beta ji pressure. Starting with the pressure. So what is pressure ka SI unit? So how we are going to write the SI unit? You always go with the 7 units. You always take the help of 7 units and then you write the SI unit of pressure. So we all know that pressure is equal to force per unit area, and we know that force is nothing but what? Newton area per meter square. Per meter square. Okay. So this is the pressure, and this is nothing but called as Pascal. Newton per meter square is known as Pascal. So what is SI unit of pressure bolo beta ji? What is the SI unit of pressure bolo? Pascal. So Pascal will be the SI unit of pressure. Okay. Now in our study of chemistry, most of the time we are not going to use the Pascal. Pascal we will be using in physics, but not in chemistry, not in my subject. We have to use, we will learn dimensions, sir. Yes, you will learn in physics, yes, definitely. So in Pascals, we are going to study, at ATM, this is called as atmospheric pressure. So in our chemistry, we generally talk in terms of atmospheric pressure. 1 atm is the atmospheric pressure. That means the pressure present in the atmosphere on the sea level, whatever is the pressure observed, that is called as atmospheric pressure. But in chemistry, we have different units for pressure. depending on the conditions. We want a smaller unit, we want a bigger unit. Accordingly, you need to handle different unit. Beta ji, this is very, very important. Please focus. And I'll tell you, even my students, they're not able to do the interconversion in the unit. So this is very, very important. Let us focus on that. Okay, so please remember, 1 atm is equal to how much Pascal? So 1 atm is equal to 101,325 Pascals. Please remember this value. How much is 1 atm? 1 atm is equal to 101,325 Pascal. Now I can write this value as 101.325 Pascals. Okay, 101.325 Pascals. Very good. Kilopascals, sorry, kilopascals. Now I can remove 2 points over here. So this will be 1.01325. This is called as bar. This is called as bar. So how much is bar? So 1 atm is equal to 1.01325 bar. So bar is also unit of pressure. Atm is also the unit of pressure. Pascal is also the unit of pressure. You will see that in different conditions we'll be using different units. For now I can't tell you where we are going to use this, but this is very, very important. Okay. So 1 atm. Acha, there is one more unit. 1 atm is equal to 760 mm of Hg. So actually mercury liquid, you study in physics, yeah, rho gh, you study all those things. So in physics we have a measurement by the height of the mercury. It applies certain amount of pressure. As mercury moves up and pressure will come. Okay, so that is 760 mm of Hg. And you can have one more which is equal to 760 torr. This is also the unit of pressure. 760 torr. So what is mmHg? 1 mmHg is equal to 1 torr. So these are the units, beta ji. These are the units which you will need during the study of chemistry. So one is Pascal, which is a SI unit. Then we are having atm. Most of the time we'll be using the atm pressure because that is the pressure present at the room temperature. At room temperature we have this pressure. Okay. Then we have the pressure of bar, and then we have the pressure of torr or mmHg. So these are the unit conversions for pressure. Please remember, beta. Is it clear to everyone? Give me a thumbs up quickly. Is this pressure unit conversion clear to everyone? Give me a thumbs up, guys. Unit conversion for pressure, is it clear to everyone? Unit conversion, this pressure ka unit conversion, is it okay to everyone? One mmHg, beta ji, 1 mmHg is equal to 1 torr. Okay. Okay, please remember these values, very, very important, very, very important. Now, we are coming to the next one, which is called as temperature, okay. So, what is the unit of temperature? What is the SI unit, bolo beta ji? So, SI unit of temperature is Kelvin, jiska symbol kya hota hai, bolo beta ji? K, right? Now, we all know that temperature in Kelvin is equal to temperature in degrees Celsius plus what, bolo beta ji? 273.15. 273.15. Okay, very good. So this is the temperature in Kelvin. If I have 1 degree Celsius, how much will be temperature in Kelvin? So 274.15. So generally the room temperature is how much, bolo beta ji? 25 degrees Celsius. So if you want to measure temperature in Kelvin, this will be 25 plus, bolo beta ji, how much? Plus 273.15. So the value comes out to be 298.15 Kelvin. So this is the room temperature in Kelvin and this is the room temperature in degrees Celsius. So these both units are going to be extensively used in chemistry. Very often we are going to use both units, temperature in Kelvin and temperature in degrees Celsius. I think all of you know this, right? Temperature. I think all of you know. So it is not a big deal. Acha, I have one question for you. Let us say that we are having a Celsius scale, and I am having Kelvin scale. एक बेटा जी हमने स्केल लिया Kelvin scale and on one scale we are having Celsius. If I change delta T, change in temperature, delta T. So if I change the temperature on Celsius scale by 1 unit, listen to my question carefully. If I change the temperature delta T on Celsius scale by 1 unit, by how much unit, bolo beta ji? 1 unit. If I change the temperature on Celsius scale by 1 unit, what will be change in temperature on Kelvin scale? Tell me fast. My question is, if I change the temperature on Celsius scale by 1 unit, what will be change on Kelvin scale? Somebody is saying 273.15. Devanath is saying 1 unit. 1 unit. Somebody is saying 273.15. Okay, 273.15. Some of you are saying 1 unit. Okay, so all of you who are saying 273.5, beta ji, you are not using your mind. See, I have asked you change. Change whether you do on degree Celsius scale or you do on Celsius scale or Kelvin scale. Change will be 1. Change is not 273.5. Okay, most of you are going with 273. Please don't do that, beta ji. Please don't do that. See, 274 degrees Celsius minus 273 degrees Celsius. You convert this into Kelvin. Change will be always below beta ji 1. If you add 273 plus 273 plus 273, now this is Kelvin, isn't it? But change will be always 1. Change will be always 1. Is it clear to everyone? Yes, change will be 1. Change beta ji kabhi same आएगा. इधर देखो इधर 1 degree Celsius to 2 degree Celsius. What is the change in temperature? 1. Now change in Kelvin scale. Kelvin पे change करो बेटा जी. 1 will become 274.15. Very good. और ये क्या बन जाएगा चेंज बोलो बेटा जी 275.15. कितना चेंज आया बोलो. What is the change? Change is 1. Change will be always 1, not 273. Still some of you are saying 273. I'm asking what will be change. Change, not the value. Is it clear to everyone? So change will be always same whether it is Kelvin scale or Celsius scale. So whenever we are calculating delta T, either you calculate degree Celsius or you convert Kelvin. See, when we are calculating change in temperature, either you calculate degree Celsius scale or you calculate on Kelvin scale. It doesn't matter. It doesn't matter. It doesn't matter. You know. So please remember, don't convert degree into Kelvin. If you are calculating change in temperature, don't convert the units. You'll see there is a chapter in solution. जहाँ पे पढ़ोगे depression in freezing point, elevation in boiling point. You know, so you are going to measure the change in temperature. Most of the students, what they will do, they will convert degree Celsius into Kelvin. अरे भैया कैसे करोगे यार? Change will be same. I hope this is clear to everyone. Give me a thumbs up quickly, guys. I think everybody understood. Okay. Very, very clear. Please don't forget it, beta ji. Please don't forget it. This is very, very important. Change will be always same, whether it is Celsius or degree. Don't convert the units. Okay, very good, very good. Okay. Okay, most of you have understood. Now, coming to the next one, which is called as volume, So let me start with the question, guys. How much is 1 ml? In terms of, let me ask like this. Let us say like this. 1 centimeter cube, which is also known as 1 cc, is equal to how many liters? 1 cc or centimeter cube is equal to how many liters? Anybody can give me the answer? 1 cc, which is also known as 1 centimeter cube, is equal to how many liters? Somebody is saying 1000. Wow, guys, wow, what you have studied in high school, I don't know. Ashwini, really, is it 1000, beta ji? What you have studied, guys? Some of you are saying 1 by 1000. 0.001. Some of you are saying 1000. Beta ji, look into it. What you are doing, beta? Is it 1 cc, 1 ml? Yes. 0.001 liters. Yes. Some of you are saying 1000, not 1000. Where you have studied all these things, beta ji? 0, Shriya, 0. Really? 0.001. Very good. So it is 1 by 1000. Okay, let me ask one more question. 1 decimeter cube is equal to how many liters? 1 decimeter cube is equal to how many liters? Tell me, beta ji. 1 dm cube is equal to how many liters? Give me the information. 1 dm cube, how many liters? 1 dm cube, how many liters? 1 dm cube, how many liters? Give me the answer. 0.1. 1 by 10,000. Oh my God. 0.0. Oh. 10,000. Wow. 9. 0.1. 1,000. Is it? 1,000. Oh my God. 0. 0.01. Jitendra says 1. Oh. Very, very bad condition, guys. You don't know what is unit, you don't know millicentimeter, meter, centimeter, you guys don't know. Most 99% people have given wrong answers. 99% people. Very not good situation, not good situation. Oh, 0.1. Oh, leave it, beta ji. I'll explain you. Chalo, come to this. Volume. So let me define volume for you. So how we measure volume is length into breadth into height. So this is how we measure the volume, length into breadth into height. Now let me define like this. All of you know the interconversion unit of the length. All of you know the interconversion of the length, isn't it? How do we do it? Idhar dekho, milli. Let me teach you third class mathematics. I'm teaching you third class mathematics, third standard mathematics, okay? Milli, centi, deci. Okay, let me write over here. Milli, centi, deci, meter. Don't know, maybe I need to teach you addition, subtraction also. So milli, centi, decimeter, deca, hectare, kilometers, isn't it? So we are having these units, okay? Now, millicenti. All of us know that if you go from right to left, beta ji, if you go from right to left, 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 you multiply by number 10. You multiply by number 10 when we are coming from right to left. So, okay, 1 meter is equal to how many decimeters? So, 1 meter is equal to 10 decimeters. So, you multiply by 10. But if I go 2 units, so this will be 10 into 10, which will be 10 square, which will be 10 square. Beta ji, listen everyone. Please listen. This is very, very important, and I'm telling you, more than 90% beta ji students are not able to tell the unit conversion for the volume. So this is very, very important, and you'll do so many mistakes in the papers. Okay. So be very, very patient and please understand clearly. So 1 meter 10 to the square centimeter, 1 meter how many millimeters bolo beta ji? So 10 to the power 3. So whenever, for example, 1 kilometer 10 hectare, how many deca bolo beta ji? 100. And what will be the meters bolo beta ji? 1000. Okay. So whenever we are coming from right to left, we always multiply by 10 for one unit conversion. For 1 we multiply by 10. For 1 we multiply by 10. But if you go 2, we multiply by 100. For 3, you multiply by 1000. Okay, it will go like that. But if you go in the reverse way, let us say we are moving from left hand side to right hand side. We are moving from left hand side to right hand side. Then how we are going to do it? You divide 1 by 10. 1 by 10 means what? 10 to the power minus 1. 1 by 10 means what? 10 to the power minus 1. So if I'll ask you, beta ji, 1 decimeter is equal to how many meters? So 1 decimeter is equal to how many meters? So this is 10 to the power minus 1 or 1 by 10. 1 by 10 or 10 to the power minus 1. If I'll ask you what is 1 meter into kilometers, so what you'll say, beta ji? 10 to the power minus 3. 1 meter is equal to how many kilometers? 10 to the power minus 3. Okay. Now we are going to use this to understand the volume. Now we are going to use this to understand volume. Please beta ji, pay attention. This is very, very important. Okay. So volume is equal to, as I said, length into breadth into height. Okay. So let us say that I am going to use dms. Okay. So length, starting with the basic unit, let us start with the centimeters. Okay. 1 centimeter into 1 centimeter into 1 centimeter is equal to 1 centimeter cube, which is also represented as 1 cc, which is equal to 1 ml, which is equal to 1 ml. Okay. Now, beta ji, let me write 1 dm. Unit to I can take, no, unit is up to me, I can take the unit. 1 dm into 1 dm into 1 dm. This is equal to how much bolo beta ji? 1 dm ka cube. Very good, sir, very good. Now, what about 1 dm into centimeter? Just now we saw 1 dm into centimeter. Please look into this, beta ji. 1 dm and centimeter. What is that value? Let me know. 1 dm, decimeter to centimeter, decimeter to centimeter, multiplied by 10. Multiplied by 10. 1 decimeter is equal to 10 centimeter. Okay. So, this will be how much? 10 centimeters into 10 centimeters into 10 centimeters is equal to how much? 1000 centimeter cube, which is also 1000 cc, and we know that it is how much? 1 liter, which is equal to how much? 1000 ml means what? 1 liter, isn't it? So what is dm cube? 1 liter. Please remember, what is 1 dm cube? 1 liters beta ji. 1 dm cube is equal to 1 liter. I hope this is clear to everyone. Okay. 1 dm cube is equal to 1 liter. Okay. Now let me ask you, what about 1 meter? 1 meter into 1 meter into 1 meter, which is equal to 1 meter cube. So what will be in liters? What will be liters and ml? Okay. So 1 meter could be written as 10 dm. Idhar dekh lo beta ji. Please look into this. 1 meter, how many dms? 10. 1 meter, how many dms? 10. Okay. So 10 dm into 10 dm into 10 dm is equal to how much? 1000 dm cube. 1000 dm cube means what? 1000 liters. 1000 liters. If I'll convert this into cc, 1 liter is equal to 10 to the power 3. So this will become 10 to the power 6 ml or cc. Okay, is this clear to everyone? Volume conversion unit, clear to everyone? Give me a thumbs up, guys. Volume unit conversion, is it clear to everyone? Give me a thumbs up, guys. Volume unit conversion. Have you learned something new today? Have you learned something new today? Is it clear to everyone? Tell me, guys. Tell me, guys. Yes? I hope now you are never going to forget the volume interconversion. We are never going to forget the volume interconversion, beta ji. This is very, very important. Okay. I hope all of you understood. Okay. Very good, very good. Great, guys. Okay, so now we are moving ahead. So we have understood what is volume, temperature, pressure ka units ka interconversion. We have understood something very, very important, which is very fundamental, beta ji, but very, very needed. Okay. Now, I'm going to start with the something called as atom ka mass. So now my topic is to become atomic mass. Okay. So to define atomic mass, what is needed? What is needed to define atomic mass? Now, beta ji, now everyone, I want your focus 110%. We are coming to the concept of atomic mass, molecular mass, and this is the basis of the chemistry, beta ji, basis of chemistry. Okay. Now, how we define atomic mass? Now, scientists start to think how to define the atomic mass. Now, if you take a small speck of dust, book suggests that if you take one speck of dust, it contains approximately 10 to the power 16 atoms. Oh my God. One speck of dust contains how many atoms? 10 to the power 16 atoms. Right? Now, one atom is so small that we can't even see. And one speck contains 10 to the power 16 atoms. Are we ever going to measure their mass? Can you measure the mass, beta ji? Can we measure the mass of speck of dust? It contains atom. How much atom? 10 to the power 16 atoms. Can we measure the mass? We'll go crazy. We can never measure the mass of one atom. One speck contains 10 to the power 6 atom. One atom ka mass. How can I measure, sir? How can I measure? It's very, very... Speck means, beta ji, kaise bataye? You take a dust particle. One small dust particle goes to speck of dust. Okay. So, speck means, beta ji, small particle of dust, something like that. So, how to define mass? How to define atomic mass then? So scientists started to think how to define the mass, how to define the mass of atom. So they said, okay, we can't define the mass by measuring it. Definitely I can't measure. But what I'm going to give is, I'm going to have a standard mass, which will be used as a reference. And then I can use this reference, then standard mass ka reference, then I can use this reference to find out. See, if you are saying at all nucleons, right? Some of you are saying all nucleons. Very, very good. All nucleons. Mass of neutron, mass of proton. How much? 10 to the power minus 24 gram. Oh my God. 10 to the power minus 24 gram. Beta ji, who is going to measure that? And how electron and proton are measured? So this is very, very difficult. Okay. So standard mass we are going to put, which will be used as a reference. And with this reference, we will calculate relative mass. So we won't be able to find exact mass. But we are going to find the relative mass. Okay, sir, I understood. What I'm going to do is I'm going to find the relative mass. What I mean is, beta ji, let us say you take the 1 kg. Okay, so you have a mass of 1 kg, right? How you measure it? 1 kg. Who has defined 1 kg? Scientists have defined 1 kg, right? 1 kg could have been more than 1 kg. That value has defined by us. With respect to that 1 kg, somebody is called as 2 kg. something is called as 3 kg, something is called as half kg, but you need to put a reference. Without reference it is not important, it is not possible, right? An atom ka mass to definitely we can't measure, so we will put a reference. And what was that reference? That reference was called as atomic unit of atomic mass, unit of atomic mass. So this was says as 1 AMU, atomic mass unit. So people have a reference. What is the reference? Unit of atomic mass, known as atomic mass unit. So atomic mass unit was taken as reference. Atomic mass unit was taken as reference. Now tell me, sir, what is this AMU? So according to SI convention and all, they said that what is atomic mass unit? 1 AMU is equal to 1/12th mass, 1/12th mass of one atom, not all, one atom of carbon-12, So 1/12th mass of one atom of carbon-12 was defined as 1 AMU, Now this is our reference, beta ji. With the help of this reference, we are going to measure the masses of other element or other atom with the help of this reference, okay? So, sir, 1/12th mass of one atom of carbon-12, what is carbon-12, sir? Can't you write carbon only? Okay, why I am writing carbon-12? Because carbon ka there are two isotopes, beta ji. Carbon ka there are two isotopes. Because carbon ka there are two isotopes, one is called as carbon-12, one is called as carbon-13. So it is not with respect to carbon-13, it is with respect to carbon-12. So scientist says that, very good, 1/12th mass of one atom of carbon-12, let us consider a reference. And what that reference was called as? This reference was called as 1 AMU. And this reference was called as 1 AMU, and which is nothing but actually mass of proton or neutron, which is approximately 1.67 into 10 to the power minus 24 grams. Okay, I'll come to this later. For now, I have a reference. What is that reference mass? Reference mass 1 AMU. Okay. Now, let us say that I want to measure the mass of oxygen. Wow. Let us say I want to measure the mass of oxygen, atomic mass of oxygen. So what will be atomic mass of oxygen? Tell me, sir. Oxygen atom. So what is atomic mass of one oxygen atom? What is atomic mass of one oxygen atom? How to calculate it, sir? Very simple. So we will say that atomic weight is equal to relative mass. What is relative? 1 AMU, 1/12th mass of one atom of carbon-12. This is my reference. With this reference, is anything heavier? Any heavier atom or anything less heavier atom? With respect to 1 AMU, are we having heavier atom or less heavier atom? That is my question. So with this reference, what we find is oxygen ka mass is 8 times. So what is that? Atomic weight is equal to atomic weight of oxygen atom. I am defining beta, yeah, oxygen atom. So atomic mass of one oxygen atom, and if you keep this as a reference, the value comes out to be 16. So what is the unit of atomic weight, sir? Atomic weight is unitless, beta ji. Atomic weight is unitless because it is a relative mass. So atomic weight is unitless. Please remember, atomic weight is unitless. क्योंकि इसका यूनिट क्या है? 1/12 का यूनिट क्या है? 1 AMU. And with respect to this 1 AMU, what is mass of oxygen? Mass of oxygen is 16 AMU. Wow. With respect to this one, this is 16 AMU. So AMU got cancelled out. So the value comes out to be 16. So relative mass, atomic weight is the concept of relative mass. We can never measure the mass of atom. We cannot measure the mass of atom. We are taking the relative mass. Okay. Now, from this one, I can have a formula. From this, I can create a formula. Okay. What is that formula? I can write. Please, beta, focus on this formula. With the help of this formula, I'm going to write a formula is mass of one atom is equal to, of any given element, mass of one atom of any given element is equal to what? Is equal to what? बोलो बेटा जी, इधर देखो, mass of one atom is equal to atomic weight into 1 AMU. Wow sir, it is equal to atomic weight multiplied by AMU. Atomic weight multiplied by AMU. Okay, so atomic weight is a unitless quantity. Mass of one atom, this is mass beta ji, not atomic weight. Mass of one atom is measured with respect to AMU. How much AMU? 16 times, 18 times, 20 times. Okay, let us say that. What is the mass of carbon atom? What is mass of one atom of, let us say, take any other element, nitrogen. Mass of one atom of nitrogen is equal to how much? So this is equal to atomic weight. What is atomic weight of nitrogen? Bolo. Atomic weight of nitrogen is 17. Unitless beta ji. 14. Atomic weight is unitless. Atomic weight is unitless beta ji. Atomic weight is unitless. But mass of one atom of nitrogen is atomic weight into AMU. We have seen the formula. Mass is equal to 1 by 12, which is AMU, multiplied by atomic weight. So this comes out to be 14 AMU. And what is 1 AMU, sir? So 1 AMU is nothing but mass of proton, because simplest atom we have is hydrogen, and hydrogen contains only one proton. Hydrogen, protium, not deuterium, protium. Mass of proton, which is equal to 1.67 into 10 to the power minus 24 grams. Okay, beta ji. So this is the definition how we are defining atomic mass. Mass of one atom, but atomic weight is a dimensionless quantity, unitless quantity, because it is a relative mass ka concept. Acha, give me a thumbs up, guys. How many of you understood, sir? How many of you understood? Please, beta ji, let me know how many of you understood atomic mass. Give me a thumbs up, guys. समझ आया atomic mass? समझ आया everyone? Okay, guys, okay. Now, so we have understood 1 AMU. Now, sir, in the books, I have seen in the books that books में तो ऐसा लिखा रहता है sir, 12.01. In the book, sir, the mass is not 12. The mass is written as 12.01. Why is that, sir? Either it is 12.01 or somewhere it is written as 12.01 AMU. So if you are talking about atomic weight, unitless quantity, in the periodic table, if you will see, the value will be 12.01. And if you talk about mass of one atom, so this will be 12.01 AMU. Sir, why this is 12.01? I to know the mass of carbon should be 12.0. But you are saying the value is 12.01. I don't understand this. Why it is 12.01? Can anybody tell me why it is not exactly 12? Why this is written as 12.01? Can anybody tell me why it is 12.01, not exactly 12? Can anybody give me the answer for that? Why it is not? Extra electron mass kahan beta ji? No, absolutely nonsense. Why it is 12.01? Why not exactly 12? That is my question, guys. No, approximate value nahi beta ji. Why we are saying approximate value? No. Definitely not. Mass of electron 10 to the power minus 31 beta ji. 1000 times. Very less. Relative mass, no. Approx. No, this is exact value. 12.01 is exact. It is written like, abundance. It has isotope. Rishi Vardhan. Very good beta ji. Very good beta ji. Isotope ka concept is there. So there is something, no. There is something called as average atomic mass. Average atomic mass. So what is average atomic mass, sir? I don't understand. So every atom, most of the elements are having their isotopes, isn't it? So elements ka subatomic particle, element ka fundamental particle atom, and atom has their isotopes. So carbon has two isotopes. One is called as carbon 12 and one is called as carbon 13. One is called as carbon 12, one is called as carbon 13. So what is their abundance in the nature? What is their relative abundance? Relative abundance in the nature. So what is their relative abundance in nature. What is the relative abundance in nature? So it was found that beta ji, that carbon 12 is 98.9%. Oh wow. So this is 98.9%. So how much will be carbon 13? I guess all of you know that 1.1%. Okay. So carbon 12 was found to be 98.9% and carbon 13 was found to be 1.1%. And what is the mass of carbon 12? So carbon 12 ka mass is 12 AMU. Mass of one atom of carbon was found to be 12 AMU. But the mass of carbon 13, why it is written as 13? Because its mass was found to be 13.00335 AMU. So this was the mass of carbon 13, which is in the atmosphere 1.1%, and 98.9% is the carbon 12, which is having 12 AMU mass. Now in the atmosphere we are having both beta ji. We are having carbon 12 as well as we are having carbon 13. Therefore, I can't write the mass 12 AMU, or either I can't write the mass 13. 13 is the very less. Approximately you say 12, but 12 is not correct. So we have to measure average mass of these isotopes. So relative abundance, which is having more abundance, carbon 12 in the nature is more in comparison to the carbon 13. So we need to write the average atomic mass. We need to write the average atomic mass. So what is average atomic mass? Abundance of carbon 13, carbon 12, which is 98.9, isn't it? So 98.9 divided by 100. This is the number. This is the abundance we are having. And how much is the mass? Mass is how much, Bulbataji? 12. Plus, what is the abundance? What is the abundance of carbon 13? So this is 1.1 into, divide by 100, percentage into the number, divide by 100, into what? Into 13.00335. So this is also AMU. This is also AMU because we are measuring for one atom. So this comes out to be, you can write like this also, 98.9 into 12 plus 1.1 into 13.00335 divided by 100. If you do like this beta ji, the value comes out to be 12.01 AMU. So what we write is average atomic mass. So we include all the isotopes present in the periodic table or other nature. We write all the isotopes present in the nature, and that is how we calculate the average atomic mass. So what should be the formula of average atomic mass? Average atomic mass is, what will be the formula, Bata ji? What is average atomic mass ka formula? Average atomic mass is equal to relative abundance of one isotope into their atomic mass plus relative abundance of another isotope into their atomic mass. Okay, divided by 100. If it is more than two isotope, you multiply 1, 2 plus 3 will come. If there is more than 3, 4 will come, and you divide by 100. That will be average atomic mass. Therefore, beta ji, in the periodic tables, you will not find 12, you will find 12.01. Is it clear to everyone? Is average atomic mass ka concept clear to everyone? Give me a thumbs up, guys. Is it clear to everyone? Average atomic mass ka concept, is it clear to everyone, guys? Tell me, average atomic mass, is it clear to everyone? Average atomic mass, is it clear to everyone? Therefore, we write like this number. Okay. This is average atomic mass ka concept. Okay. Very good, beta ji. Hemant, bahut badhiya beta ji. Very good. Okay. So this is all from my side. Tomorrow, we'll start with the concept of molecular mass, and then we'll go for the mole concept. And then we will start the mole concept. And as you all know, mole concept is the foundation of chemistry. If you don't understand mole, you will be gol. You know, in Hindi they say gol means gayab, evaporated. So if you don't understand mole, you'll be gol. So we need to be present in tomorrow's class. This is very, very important. Mole is very, very important. Most of the students will suffer into the mole concept. So we need that. So all of you, please come tomorrow. Take care and bye. Are you guys enjoying the class? Yes? Are we enjoying the class? We are having a good time with chemistry, yes or no? We are having good time with chemistry, isn't it? Yes? Yes. Great, guys, great. Study well, study well. Make chemistry your strongest subject, okay? Make chemistry your strongest subject because it helps a lot during the preparation. It helps a lot about, getting good marks, because this doesn't need your much time, okay? With less time you can do very well. That is the plus point of having a good command in chemistry, okay? Thank you everyone. Thank you guys. Thank you so much. Bye. Okay.